Hello, this is Sal. We have this video. This is a CCNA Security Lab Skills Integration Challenge. We have in this network ASA device. It's a Cisco security device that combines firewall, antivirus, IPS, and VPN capabilities. It provides proactive threat defense that stops attacks before they spread through the network. It has two VLANs, which we didn't configure yet. VLAN 1 for inside network and VLAN 2 for outside. In the outside VLAN network, we have two switches in the inside VLAN, and the two switches are connected to these two PCs. And both switches are connected by a trunk port. We have the PCC on this side representing the branch office. We will configure SSH so the branch office have access to the inside network. We will configure, as you see in the objectives, side-to-side VPN. Also, we will configure the firewall and the IPS setting and configure the ASA basic security firewall setting. Let's start by configuring router 1. Enable conf D. We will enable password of Cisco and configure a username admin1, giving this user a privilege of 15 and password as admin. Username admin, privilege 15, password admin. Now we want to, or we will configure AAA location, local authentication on router 1. AAA, new model. And then we need to implement AAA services using the local database as the first option, and then the enable password as the backup on router 1. AAA authentication, login, default, local, enable. Now we'll configure SSH on router 1. First, let's configure the domain name, CCNAsecurity.com, IP, domain name, CCNA security.com. Now let's configure the crypto key, generate RSA, and we'll give it 1024 modulus bits. And we want only SSH version 2 and only SSH allowed on router 1. IP SSH version 2 and only SSH to be used on router 1. Line VTY 0 or transport input SSH. Let's verify that PCC can access remotely router 1 using SSH link admin 209.165.2.233 admin enable, and the enable password is Cisco. So we have a connection between PCC and router 1 using SSH. Now let's configure site-to-site IPsec VPN on router 1. Open router 1, exit. Now let's configure access list, extended access list with number 101, and to permit the traffic from the loopback of router 1 network 172.20.1.0 to this network. So access list 101, we want to permit the IP from the loopback of router 1 172.20.1.0, the wildcard 0.0.0.255. We want to allow it to this network, which is 172.30.3.0. 172.30.3.0 with the wildcard 0.0.0.255. Now we configure the access list. Now let's configure the crypto ISACAM policy. Give it the sequence number 10 on router 1. And the shared key we will use here is shared crypto key Cisco. Crypto ISACAM policy 10. Now let's configure the authentication. Will be pre-shared encryption AES 256 hash SHA group key exchange Diffie-Hellman group 5 lifetime 3600. The ISACAM key would be Cisco, and this what would the destination address be using to establish the secure communication between router 1 and router 3. So here, exit, crypto, ISACAM, key, Cisco, address, the address from router 1 will be 10.20.20. This interface on router 3, 10.20.20.1. Now we will create the transform set, VPN set, we call it VPN set, to use ESP AES 256 to encrypt, to transform encryption, and transform set, as I mentioned, will be VPN set, and transform authentication will be ESP SHA HMAC. Crypto IPsec transform set VPN set ESP AES 256 and ESP SHA HMAC. Now crypto map name would be CMAP, crypto map we will use sequence number 10 and identify it as an IP6 ISACAM map. Crypto map CMAP 10 crypto map CMAP 10 IPsec ISACAM. Now we will set the destination address, which is router 3 IP address. This address, this is the destination. So set here 10.20.20.1. Set PFS, which is the perfect forward secrecy, would be group 5. No space between group and number 5. Set transform set, it will be the VPN set. Now we need to match the address of the access list number 101. Exit. Now we need to bind the crypto map, the CMAP we created, to the outgoing interface on serial 010 of router 1. Interface serial 010 crypto map CMAP. Let me double check what we did so far. Show crypto IPsec ASA. Now we will repeat the site-to-site VPN configurations on router 3 so that they mirror all configurations from router 1. So we will start by creating the access list on router 3. Enable, configure terminal, access list 101, permit IP from this network 172.30.3.0 to 172.20, the loopback of the 20.1.0, the loopback of router 1. So we want to permit IP from 172.30.3.0 on the wildcard subnet mask to router 1, 172.20.1.0, 0.0.0.255. Now the crypto ISACAM policy, and we'll give it number 10. Crypto ISACAM policy. Now the authentication, it will be pre-share, encryption, AES 256, and the hash SHA, and the key exchange, the Perry-Hellman key exchange will be group 5, lifetime, just like what we configured on router 1 3600. Now the internet key exchange are the same. Now ISACAM key would be Cisco, as we configured it on router 1, and router 1 now is the destination for router 3, and they must use the same key to establish the secure communication. Here, exit, ISA camp, yeah, sorry, crypto, ISA camp, key, Cisco, address, the address will be this address of router 1, the peer 10.10.10.1, 10.10.10.1. Now we will create a transform set, VPN set, and the encryption will be ESP AES 256, and the authentication will be ESP SHA HMAC, just like what we configured on router 1. Crypto, IPsec, transform set, VPN set, ESP AES 256, and ESP SHA HMAC. Crypto map name would be the same, CMAP. We'll use sequence number 10 and identify it as IPsec ISACAM. Enter here, crypto map, CMAP 10 and IP6 ISACAM. Now we want to set the destination address, which is router 1 IP address. Set here, it will be this 10.10.10.1, 10.10.10.1. Set the PFS and the perfect forward secrecy group 5, the same, no space, and the transform set will be the VPN set. Now we want it to match the address of the access list, match address 101. Exit. Now we want to bind the crypto map, the CMAP, to the outgoing interface. It will be serial 011 here from router 3. Interface serial 011. Crypto map, C map. Show crypto IPsec SA. Now let's ping loopback 1 interface from PCC. Ping 172.20.1.1. We received a ping, the reply. Now on router 3, let's run this command again. Show crypto IPsec SA. You see now, because I ran the ping twice, we have packets encapsulated 7, packets encrypt 7. So this is done. We configured site-to-site IPsec VPN in a very easy way. Now let's move to another subject, to configure firewall and intrusion prevention system. We will configure a zone pair firewall on router 3. Let's bring router 3 again and work on it together in a very easy way. We will create two zones, a zone named in zone and another zone named out zone. County, zone, security, we call it in zone. Zone security, we call it out zone. So this is what we did so far, just creating an in zone and out zone on router 3. Then we will create an extended access list. We will give this access list number 110 that defines internal traffic, which permits all IP protocols from this network 172.30.3.0, the subnet mask 24, source network to any destination. Exit access list, we'll give it number 110, permit IP 172.30.3.0 with a wildcard 0.0.0.255. Can access any network. Then the explicit deny from any source to any destination. Access list 110, deny IP any. Now we will create a class map named internal class map that uses the match all option and access list 110. Now class map type inspect. We want it to match all, not to match any. Match all internal. This is the class map we are creating. Class internal class. Sorry, map. Enter. Match all option and access control list 110. Match access group 110. Enter. Then we will create a policy map named in to out policy map, from in zone to out zone policy map, that uses the class map, internal class map, the one we create to inspect all match traffic. Policy map type inspect in to out policy map. Class type inspect, internal class map. Inspect. This is the action we want. Now we will create a zone pair named in-to-out zone pair that identifies in zone as the source zone and out zone as the destination zone. Exit. Zone pair, security, in, to, out, zone pair, source. Our source will be the in zone and destination zone pair, source will be in zone, destination out zone. Enter. Now we need to specify that the in-to-out policy map policy is to be used to inspect traffic between the two zones. Service policy type inspect in into out policy map. Exit. Now we'll assign gig 001 this interface as an in zone member and serial 011 as out zone. In zone, out zone. Interface 0 1 sorry 0 0 1 zone member security and in zone member exit interface serial 0 1 1 zone member security out zone. Now we need to configure an IPS on router 3 within packet tracer. The routers already have the signature files imported and in place. They are the default XML files in Flash. Now on router 3, show Flash, we have the signature for category on the XML file and the default also here. For this reason, it is not necessary to configure the public crypto key and complete a manual import of the signature files. Now let's create a directory in Flash named IPS dir. Make directory, call it IPS dir. Confirm it. Let's double check. This is what we created. And now we need to set it at the location for IPS signature storage. We made the directory. Now it's time to configure terminal, sorry, IPS, config, location, flash, IPS dir. Now we want to create an IPS rule. We will name it IPS rule. IPS name, IPS rule. Enter. Now we want to retire the all signatures category with the retire true command. All signatures within the signature releases. So in IPS signature. Sorry about that. And the category all. See the options: retired, true. Exit. Now we want to unretire the iOS IPS basic category using the retire false category iOS IPS basic. Retired false. Exit. Confirm. Now we need to apply the rule inbound on router 1. On the serial S. Sorry, on router 3 here. Interface serial 0 1 1. IPS rule inbound. Now we are done with the configuration, and let's move to another subject. Now we will configure ASA basic security and firewall settings on the ASA on here. Now we need to configure VLAN interfaces. For the VLAN 1 interface, inside VLAN, we will configure the addressing to use this IP address 192.168.10.1 for VLAN 1. Subnet mask 255.255.255.0. Enable. No password configured yet. Comp T. Enter VLAN 1. Security level of 100. Now we will remove the default DHCP setting and configure the addressing to use. No IP address DHCP. IP address 192.168.10.1 255.255.255.0. Name interface, name F inside. Now we will do the same for VLAN 2. But we also need to remove the default DHCP setting and configure the addressing to use 209.165.200.234/29. Enter VLAN 2, name F, name interface, outside, security level of 0 for the outside, no IP address DHCP. IP address 209.165.200.234, subnet mask 255.255.255.248. Enter. This interface E00, this for the outside VLAN 2. Now let's configure a name for a host name for exit. Give it a host name. We call it CCNA. The domain name CCNAsecurity.com. Domain name CCNAsecurity.com. And we want to enable password of Cisco. And also we want to configure a local user account named admin with password admin. Just easy to remember and easy to work with, but in real world you need to use something nobody will guess, or an easy password like Cisco or CCNA for username admin, password admin. Now we will configure AAA to use a local ASA database for SSH user authentication. AAA authentication SSH console local. We need to allow SSH access from the inside host. So with SSH, the inside host or network 192.168.10.0, the network 255.255.255.0, and this is inside. The same we want to configure or to allow SSH access from the outside. The host, just this host, 172.30.3.3. SSH 172.30.3.3, subnet mask 255.255.255.255 outside. We use the 32 subnet mask because it is just for one host, just this host, PCC. Enter. Now we will configure the ASA as DHCP, assigning IP addresses to inside the HCP clients with this range from 192.168.10.5 in this network to the range up to 30. So we'll do it this way. DHCP address 192.168.10.5 to 192.168.10.30 inside. Now we need to enable the HCP to listen for the HCP client requests. DHCPD enable inside. We are done with configuring the DHCP for the ASA. Now we need to configure static routing and NAT. Create a static default route to the next hub router, router 1, address on this interface. Route outside 0.0.0.0 with subnet mask 0.0.0.0 means everywhere is through this interface on router 1. 209.165.200.233. Enter. Now we want to create a network object named InsideNet and assign attributes to it using the subnet and NAT commands. Object. What is the object? It's network. What are we gonna call it? InsideNet. Now, what are the options do we have? We have subnet and NAT. Subnet, it's the inside network. It's 192.168.10.0, 255 space there, 255.255.255.0. Now we need to create a dynamic NAT translation to the outside interface. NAT inside, outside, dynamic on the interface. Now we are done with configuring NAT. Now we will work on modify the Cisco modular policy framework MPF on the ASA and using the following settings. First, we will configure a class map named inspection underscore default to match the default inspection traffic, and then exit to global configuration mode. Exit. Configure key. Class map. We will call it or name it inspection underscore default. Match. We want it to match all of this. So default inspection traffic. Default inspection traffic. Exit. Now we'll configure the policy map list global policy. We'll enter the class inspection default and enter the command to inspect ICMP, then exit to global configuration mode. Policy map. Call our policy map global underscore policy. Class inspection underscore default. Now we want to inspect what? This is where we can choose what we want to be inspected. ICMP, TFTP, HTTP, FTP, but in this example we will work only with the ICMP. Exit. Now we'll configure the MPF modular policy framework service policy to make a global policy apply global. Service policy global underscore policy global. And by this we configured everything, all the objectives we talked about. Hopefully you learned something from this video. I'll work on more videos and put all my experience or all my knowledge or what I know. So just to make sure that networking is easy if you follow the rules and you keep digging for any information and keep practicing and follow up with whatever a new technology out there about networking. Wish everybody the best. I hope I was helping. It took me a while working on this network, just trying to make it really easy to grasp and to understand that it is not scary. It is just follow the rules, follow the steps, and keep reading, keep digging, keep doing your searches. This is Sal. I am certified so far with CCNA Security, working on advance my career and my knowledge in networking. Wish you all the best, and thank you for watching.